in what Andrea just talked about with data, sensors, agency partnerships. We'll talk a little bit about that in this presentation. I'm specifically going to talk about an application that TTI helped develop for the Houston region through our partnership with Houston Transtar. I'll talk about what Transtar is a little bit in a minute. And that specific application is the roadway flood warning system. So next slide. I'm going to go through the agency partnerships and why the partnerships in developing something like this was so critical. The problem we're trying to solve, the concept that we use to solve it, show you some of the applications that were developed as a result, and show you how it's being used and additional research that's being done. And hopefully at the end, you get a good overview of what we were able to accomplish by synthesizing resources from multiple government agencies. Next slide. So Houston Transtar is important to this. It's basically the 4 government agencies in the Houston region that are responsible for the transportation and emergency management functions. That's Harris County, the Texas Department of Transportation, Houston Metro, which is the transit agency, and the city of Houston. And they all leverage each other's software, data, and even personnel resources to perform the functions of transportation and emergency management. TTI's role in this is to kind of provide facilitation and guidance among the agencies in terms of technical solutions that might span multiple agencies. Next slide. So the most visible part of the partnership, there's a lot that goes on: incident management, planning, emergency management on an everyday basis, but the most visible part is kind of the traveler information component and the traffic management component, really focused on providing information to stakeholders on all types of roadway conditions, incidents, road closures from multiple agencies. You see this as a result of on websites, mobile apps. Transtar has its own mobile app on website, provides information to TxDOT and a lot of the media. And then of course, social media utilizes the information. And so highly, just Transtar's website alone gets about 550 unique website visitors per month, so highly utilized. Next slide. So that value of the information goes up exponentially during what we call emergencies. And so not only are they providing information on the other stuff that I talked about, but then information on weather, flooded roadways. And we see this every time we have an event in Houston. And I'll talk a little bit about Hurricane Harvey in a minute, but during the Harvey event, over the course of about 5 days, we had over 3 million website users. So really, a lot of use during these events. People are relying on the information. You see that in the next slide, where we compare the website users during an emergency event in the red versus the website users on a normal day, that's in the blue. And so usually with website usage alone, it's 5 to 10 times what it is on a normal day when we have widespread regional flooding or emergency events. And unfortunately, in the Houston region, these aren't rare occurrences. Between 2011 and 2024, we had at least 3 days per year where widespread regional flooding occurred. So it not necessarily have to be a hurricane or a tropical storm. It could just be a summer storm where we have a lot of rainfall, high rainfall rates causing a lot of street flooding. Next slide. So Hurricane Harvey was obviously a huge event for the region. Houston region alone received from 30 to 40 inches of rain over 5 days. Over an area the size of, I guess, the state of Connecticut is what I've heard. And during that event, information on flooded roadways was confirmed and provided via cameras. TxDOT and Harris County has an extensive camera network along the roadways, but we were really kind of blind to what was happening outside of those areas where there were no cameras. So the question came up: how can we better detect roadway flooding, or where roadway flooding is likely occurring without camera verification, without having to rely on law enforcement and maintenance crews? Next slide. So after Harvey, the agencies, as a part of Transtar, sat down and said, how can we do a better job detecting roadway flooding? And really the key was leveraging their existing data sets, stuff that was already out there. How could we share this information, make things, make it easier to detect roadway flooding? So TxDOT, Harris County Flood Control District, TTI, and Harris County Office of Homeland Security and Emergency Management all got together and developed a concept. Next slide. So we have the benefit in the region of having one of the most robust flood warning systems in the U.S. Via the Harris County Flood Control District. They've got 280. I actually think that's a little low, and I think it's expanded. Probably over 350 sensor locations now. Collect all kinds of weather information, including rainfall rates, stream elevation, height of channels, and so really what we were interested in doing is seeing if we could tap into this data source and detect roadway flooding. This is focused on channel flooding and on lake and bayou flooding, but we wanted to see how we could make this apply to roadways. And so next slide. So we developed some data requirements for our system. We wanted specifically to get rainfall rates at specific locations. We wanted optionally to get stream elevation at locations, along with the elevation of how high the bank is, to see if the streams are out of their banks. We wanted, we were developing a real-time system, we want to get this data in real time, no older than 30 minutes, and we were interested in at least 15-minute aggregations. Next slide. So the concept of this is to warn travelers to use caution and avoid areas where conditions are likely to cause roadway flooding. Essentially, we know in these areas where there's sensors, we know how much it's raining or what the rainfall rates are, or how high the water is in the watersheds. So using this information, could we estimate where roadway flooding is likely? This system is really focused on real-time conditions and not future prediction, like what's happening now. And I want to also stress that it's not definitive confirmation of flooding, but estimates, based on the data that we see from all these different sources. I mean, and for the most part, our goal is to get people to stay off the roadways in these areas if at all possible. So this is what the system attempts to do. Next slide. So we developed a number of applications around this. These are snapshots of the website presentation of it. We highlight areas around sensors that exceed rainfall thresholds, 3-mile radius. We worked with our Harris County Flood Control District folks to determine, what should those thresholds be for our region. Those thresholds are based on curb and gutter drainage systems in flat coastal plains like Houston is in. So the thresholds may vary in other types of topography. The system updates every 15 minutes, and when a threshold is exceeded, they're displayed for 90 minutes and an additional 90 minutes for after each subsequent report. For the most part, if it varies a little bit depending on where we are, but if it rains more than an inch in 15 minutes, there's going to be roadway flooding in the area. So that's the basic threshold we use, but there's some various thresholds for other things. Next slide. So this information obviously gets pushed out to different websites via social media. We have mobile apps that use it. With the mobile app, they're location aware, so obviously users can get a kind of a more focused area when they enter an area where there's flood warnings actually occurring. The mobile apps also have the ability of sending out push notifications similar to what you get with a weather service alert. Next slide. So Houston Transtar has its own website. TxDOT also has a statewide traffic information website called drivetexas.org. And so we were able to push the information out to that. You can go to the next slide. And it utilizes the API that we developed to share this information out. So anyone can kind of connect into this information and display it on their own applications. The goal for us is to get this information out to as many people as possible, as large as audience as possible. Next slide. We've developed a number of tools to be able to kind of do post-mortem on this data. historical analytics. We can look at where flooding was likely occurring, answer questions about the performance of the system. We can select any point in history and go back and kind of get an animation of when the flood warning system was triggered. We're also utilizing this system via the APIs to integrate the data into the Texas Trust CV2X project. We have a couple of use cases that are actually going to take the roadway flood warning API data that we've generated, push them directly into the vehicles for vehicles that do have OBUs or indirect via a cellular connection to kind of give more hyper-local information, hyper-local roadway flooding information. But the roadway flood warning system that was talked about here is kind of the backbone of that data for that. Next slide. So really, the key to all this were the agency partnerships. And even though TxDOT is facilitating a lot of these efforts and paying for a lot of these efforts, hardly any of the data being used for this system is theirs. What we've done is we've gone out and TxDOT's established partnerships with a lot of flood control districts, river authorities, and NOAA, as you'll see here in a minute, to get data from these different sources and use it in their system. And so really the partnership I want to stress is key. Right now, TxDOT's working on expanding the system to other parts of the state using these creative partnerships. Next slide. So we talked a little bit, we initially started off with sensors, using sensors for the system. And obviously, we're limited by where those sensors are located. But one of the really compelling data sources that we've been able to tap into is NOAA's MRMS quantitative precipitation system. That uses radar gauge and environmental data, basically dividing the country into U.S. into 1 kilometer blocks. And given that information, we can pick any point within the United States via latitude, longitude coordinate and get an estimated rainfall rate. And this data is updated every 2 minutes. And the best thing about it is it's free for governments to use. So kind of a source that we really looked at as having a possible huge benefit. Next slide. So we were able to tap into the MRMS data from NOAA and compare it to our existing sensor data, because we have really reliable sensor data as well, just to see how does it look. And for the most part, we see differences less than 10%, which was good enough really for our system to be able to detect when roads are probably flooding. We were able to also take the MRMS data and generate historical radar data, so this helps us in being able to do post-mortem analysis of the system performance. Next slide. This is just another comparison slide of comparing the MRMS data to sensor data. And as you can see, we typically find that the rainfall differences are, these are over 24-hour period. And you may see some bigger differences when you break it down into smaller aggregations. But the rainfall differences average, are usually no more than plus or minus 10%. So like I said, for our purposes, this is good enough for roadway flood detection. Next slide. So our deployment strategy for utilizing the MRMS data is to use them in areas where we may not have sensor coverage, where there's gaps in the system, particularly in high impact travel corridors, suburban areas. You can see them circled there on the map, where we didn't happen to have sensor infrastructure installed, and there were no plans to install it, or they hadn't installed it yet. And so those circled areas, we put a number of MRMS we call virtual sensors in those locations to make the system more robust. Next slide. This shows the expansion of the system over time and the different agencies that we've partnered with. Initially, this was a Houston-based system, but it's expanded along the entire Texas coast. We're currently monitoring 586 locations. Actually, I think it's more than that. Should have updated that slide, but TxDOT is working on an effort to go even further inland, and we're looking at doing detection in the Austin, San Antonio region next, and kind of spreading up to East Texas, where there's always threats of heavy rainfall and roadway flooding. Next slide. This shows these next few slides just kind of show an animation of an event as it occurs. What you'll see is the roadway flood warnings being generated there. Those are the circles with the icons, the radar as the storm moves through. These are 2-hour advancements. And then if you go to the next slide, you see the rainfalls move off to the east, and the flood warnings, some of them still exist, some of them are being cleared. So in terms of the results of this tool, we constantly get requests for expansion. The tool is impactful. It's really a simple concept. I think the additional users of this beyond just travelers are obviously emergency management folks, freight operations, transit agencies, emergency responders. As I said, ideally we'd like people to avoid travel altogether during these flood events, but sometimes we realize that's not possible. The system's been recognized with various awards, including one from the National Operations Center. So we've got the agencies, all the partnered agencies have gotten really positive media coverage out of this. So it's been really, really good press for them. Next slide. So, really, as I said, simple concept. The data already existed. The key was just getting the right people together in a room to kind of leverage what data was already out there among government partners, transportation and emergency management folks. Not a complex concept. It's more about getting the people together to share that data. So, obviously we can't prevent these weather events. They're occurring more frequently, but by utilizing the data and kind of these creative partnerships, we can work to create these systems that'll prepare us when roadway flooding does occur. So I think this system is a great example of that. And I believe that's all I've got.